Hello and welcome. My name is Johan Holtby and this is a tutorial series on how to use threads in Unity and how you could benefit from a tool which I have made. It's called LoadBalancer and it's published in the Unity Asset Store. The tutorial series is mainly about threading in general, even though it has its base in my tool just to simplify examples. So this tutorial will be in forward implementation and event-driven top-down implementation. So this is two approaches how to use threads and how to divide your work or your code in different ways. And I will discuss the pros and cons of these two implementations. This is my own name, so I don't know if you can find them on the internet, but the thought about them is a general thought, and I have got it from here and there, picking things up. So here is the system running, and as you can see, if I press the button, it goes from the right to the left, and it's built in many steps using forward implementation. You press this button, and event-driven implementation when you press this button. And if you see it, I don't know if it's possible to see it, goes from green to turquoise to red and then to green. So from white to red to turquoise to green. And this is to represent different states. So here we have the code for demo 3 and the user interface. And here is the interesting part, the space button, and here we have it, the build button. So when you press the build button using the forward implementation, it will just call the build all spheres forward. So we go and check in this code, and here we can see build all the spheres forward, and it just builds all the spheres in forward implementation. And what that means is that it will go through the code step by step, and then the next step and the next step and the next step and the next step. So it will do it from top to bottom, but divide it so it can go from the main thread to threaded threads and so on to offload work. This is not a topical great implementation, since we will have the problem of not having a top-down implementation, which I highly suggest if you want to have clean code. For example, if you go to this build sphere forward step 1, then you see that it's just doing some stuff. Stuff is being done, and then it changes from red to cyan. You know, remember the state machine with the locks, just have it thread safe. And then do some stuff in the thread. And then the load balancer interface instance.admin thread work. And then it will build the step 2. And here you can see if it's lost the connection to it, it will try to build it using, it will just wait, lost object, waiting for object to regain the right state. This means that go to red from red to cyan, but cannot do that. It's in some other state than red. Then it will just go and just add itself build step 1 again and again and again until it's done. And then if we go to this add main thread work, let's go to the next step. Here we can see it. This is done in the main thread. So now we have the standard Unity context, and you can do all you want. And then you see this sphere, which is the object. And then you find that you can transform it to cyan to yellow. And yellow is just the intermediate step, which isn't actually viewed since it's just one frame. And then it sleeps for 20 seconds, it's doing stuff. And then the sphere is transformed from yellow to green. So this is in one frame, therefore you cannot see it. But I still have this change just to make it visible or understandable that it's changing between state, and this is something you should do in your own code. You should probably not use yellow, a more descriptive state for your object. And then if it cannot change from yellow to green, which is the final state, and it has throws an exception, access violation exception. Last time it just uses the wait if it has lost the connection. This is something you have to decide on how to handle when something is not going the way you want. You want to wait and then just add the work and add the work and add the work until it's possible to execute it. A problem with that might be that you will end up in a what's called lock, a thread lock, and this is that two threads are trying to access each other or a common resource, and therefore they cannot really continue because they're just waiting and waiting and waiting to get both of the resources, and they want them both and they only have one, for example. And then the last step, add threaded work, build all spheres forward, object sphere. So this is if it has completed. It will go to the build all spheres forward and object sphere. So if you go to this code, and you can see it just goes through all the spheres, and if the list of the objects of interest can change from white to red, this means that if anyone is left to be built, then it will start to build it, and this is in threaded context, you have to remember. So you have to think about when you're using threaded context and when you're using main thread context, because you cannot use Unity stuff in a threaded context. And when I said threaded, I mean it has threads. It runs in a separate thread, not in the main thread. Here, for example, we can see when the problems occur. If I press build and then just start clicking the state 5, you can see it crashes in state 5. And the reason for this is that 0, 1, 2, 3, 4, 5. I changed it from whatever color it is to white all the time. And then the object is lost because it should be in the state red, for example. I don't really know the exact state here, but it has lost the object and the threads are just running. You can see every frame here, it's trying and trying and trying. So it is lost in the main thread most probably. The other implementation is the event driven, and here you can see it. It's exactly the same and has the exact same problem, but here I instead throw an error. So if something is wrong in keyword system.access validation, the object have been changed during the building in build sphere, all spheres pushing to main. And you can see it only builds once, and this is because everything crashes due to the error, and it's just thrown out to the main thread in the end. One thing to think about when you're using threads, normally you will not receive these errors, but since the thread pool catches all errors and displays them as debug messages, you will receive them anyway. This is otherwise something which is kind of confusing to beginners. So if you're using threads without my tool, remember that the exceptions which are thrown might not be catched by the main system. They will just be maybe thrown out to non-existent and the thread is crashing. If we look at this in the code, build all spheres pushing to main, here you can see that we have the build all spheres pushing to main. It goes through all the spheres and it starts to find the first sphere and change it from white to red, and then do some work, and if it cannot change it will throw an exception, then do some more work, and then it will change from cyan to yellow, and then if it cannot do that it will still throw an exception, and if it now has come to this point it will start to push to the main thread. And the difference here is that you have kind of top-down approach, and this means that it's not really pushing forward, it's pushing down, and then it just comes back up again. So really, all this code could have been pushed to a separate thread, and then when it to a separate function, then just used this load balancer or this code. Maybe this code should have been a separate function. This code should have been a separate function. So normally in your system, of course, it will be, but in this system, they are just calling the sleep function, which is not that interesting to look at. And then the main work, which needs to be done in the main thread, is pushed in this line. So what this difference is that instead of doing everything one step at a time, this is doing everything from top to bottom, then pushes everything to functions, and then it waits for main, and then wait one. So this is a wait function until the add main, the build all spheres push to main is completed. So if you go to look at this, this is an auto reset indent, and this is quite neat when you're using threads. This is something you can wait for. So if we go back to the code and go to this build all spheres, pushed to main thread, you can see it does the work, and then it tries to change from yellow to green. If it cannot, it throws an exception. And then it calls wait for main.set, and this triggers this wait for main wait one to continue. So now it will release this thread and continue executing and going up and fetching the next sphere, and then going through all the steps, pushing it to the main thread. And then when the load balancer can execute it, if we go over all the work, and then it will trigger the main wait for main.set, and then the code will continue in the thread here. So they are really just using this as a semaphore or some way to speak between each other, that I'm done, now you can continue. I think this code implementation is much better than the previous one, the forward implementation, since it's much faster to get the overview of the code, because you can just go and you see at first it do the thread sleep, then it does the thread sleep, and then it does then it do this build all spheres pushed to main. And if this were some complex functions and they were just catching on and pushing to each other, and this can be a complicated thread to follow, but here you can see all the stuff which is happening in this thread, and then the details are described in this part. This part, this thread.sleep 200, is not an interesting function, but here you would normally paste your interesting functions. In the other implementation, you go from function, and in the end of the function, the forward implementation, you will call the next step, and then the end of that function will call the next step, and then continue like that until everything is done. So this was the 2 implementation strategies. Thank you for watching. Load Balancer, which I've used in the tutorial, is published in the Unity Asset Store, a link in the description. Improvements or requests, please leave them in the comments, and this part is the last one for now, but any requests or comments might trigger a new tutorial. So until next time, bye!